Hello, I'm Mike Franklin with Olympus Controls. This is a IMS Lexium MDrive. Today I'm going to show you how to connect it either via EthernetIP to a Allen Bradley CompactLogix PLC. The first step in our process will be to launch the Lexium MDrive software suite. And once that's open, you launch the Lexium MDrive Ethernet interface. Once this is open, the first thing we need to do is open the Ethernet interface. This will allow us to find the address of the MDrive and change it and to modify any parameters we need to in order to communicate with the PLC. The first step will be get on the config tab and then go down here at the bottom left to the UDP broadcast button and click it. That will bring up the IP address of the unit. Once you do that, you come up here to the connection button on the top and find that IP address and click connect. We are now connected to the MDrive. At this point, we go and we read the MAC address of the unit. And we can see that as well as we come down here to the Read All tab and read the IP address, the subnet mask, and the gateway. Here is where you will change the address of the MDrive to match your PLC, and of course you also have to make your laptop match the same thing. You make any changes here and then you click Write and it'll give you an OK message after if it took. Once you do that, you want to go over to the EIP tab. Here is all the inputs and outputs that are used for communication between the MDrive and the PLC. Our next step is to go to the EIP tab and select the I/O that we want to use to communicate with the Allen Bradley PLC. So our first step will be to go down here and get what's in the unit. This is the default settings for the drive. You can select any one of these and change it and pick the number of I/O that you want, such as acceleration, deceleration, slew rate, the max amperage. There are several that you can choose from. They're available in the manual, and you select the ones you want and then you set them by using the set button. At that point, you've configured the drive to communicate with the PLC. The only step left is to save the user types to an L5X file. So you'll come up here to the File button, click Save EIP User Types, and you have outputs and inputs. So you'll save the outputs to an L5X file. And then you save the inputs. At that point, you're done in the Lexium software suite, and in our next video we will show you how to configure the Allen Bradley CompactLogix to receive this data. Your next step will require that you use the rslogix 5000 software and you open your existing program that you're going to attach the MDrive to, or create a new program, and then select your path to your PLC, and then your next step will be to add the Lexium MDrive as an I/O module. So under your controller organizer, you go down, you find I/O configuration and open that up, find your Ethernet tab, you left click and pick new module. It's going to be a generic Ethernet module. So you select that and you click Create. You name it MDrive or something that's associated with a piece of equipment that it's tied to identify it. The data type will be sent, single integer. You have to put in the IP address that we gave the MDrive earlier. You have to set up your assembly instance, and this information is available in the manual. In this case it's 100 for the input, size 16, 112 for the output, size 36, and the configurations 1 and 0, and you click OK. This is the cyclical time in which it will read that I/O. It can be anywhere from 10 milliseconds up. The manual suggests 20 milliseconds. You click Apply and OK. Our next step will be to import the L5X files that we exported when we created the MDrive file. To do that, you come up to your File tab, you import component, data type, you open the folder Lexium MDrive where you find it, you select the MDrive inputs and you click import. It will tell you it's going to create the data type. You can edit the properties if you want to, but it's not necessary. Click OK. Once that's done, you do the same for the output L5X file. Now we're going to create our input and output tags that we'll use in our main program. To do this, you either go to your controller tags or you can go to your main program tags. I'm going to do it in the controller tags. You click Edit Tags, you create a new tag. I'm going to call it MDrive _N. You go over here, you select data type. I'm using MDrive inputs _T20. That's the L5X file that we imported. Click OK. Now, as you see here, you have the same data that we're looking at. For your inputs, you'll do one that's MDrive, and this can be any name you want it to be. Out, and again you go over here and you select, and if you start typing in your tag name, it'll bring up a list for you. So now there's MDrive out. Now we have the slew, acceleration, velocity, all those other tags that we need to use. At this point we're going to move to doing the ladder logic. Next step is to open the main routine and create our ladder logic to communicate implicitly with the MDrive. So we're going to go to the first run. We're going to put in a CPS copy synchronous file command. Our source data will be the MDrive 1I 0-bit. Hit enter. The destination is the tag that we created a moment ago, MDrive N, and our length is going to be 16. We will insert another run and we'll do the same procedure for the outputs with our synchronous copy file. Our source in this case is going to be MDrive out. The you have to pick the first bit, in this case A for acceleration. The destination is going to be the tag for the L5X file. MDrive O, data 1, the first bit, and the length is going to be 36. We are now going to write 2 runs of program to jog and stop and create a slew move to test our synchronous commands. So you examine if closed jog. We're going to move 50,000, and our destination is going to be MDrive 1 out dot SL for slew. We're going to insert another rung, and we're going to examine if close stop. We're going to create another move of 0, and our destination will again be MDrive out slew. This will allow us to verify that our program is working. At this point, you save your file, and we will now download it. So once you save your file, then you download it to the processor. At this point, we will toggle the jog and stop bits using Control T, and if everything's working correctly, the motor will take off and run. So now I'm going to show you how to read data out of the drive that isn't received implicitly. So I'll use an explicit message and I'll read the data for the control bounds. So what I'm going to do is insert another rung, and I'm going to use a tag, the Boolean tag I called get, and I'll create a message. So I'll use a message tag that was created called getCB for control bounds. I'll go in and set up the message so you get this information from the manual. Service code E is a get. The instance in this case is 1. The class is 6A, and the attribute is 2. Okay. The destination element is drive CB. The communication is going to be MDrive, and the tag is going to be get CB. You apply that and you say OK. Now we're going to download that change. One. So here I'm going to go look at the data where it says drive CB, which is right here. I'm going to go out and manipulate it and see if that data changes. You see it come up as a 2, so we know that getting that data works. We can manipulate it, change it to 0, go back, toggle the bit, and we see now we're reading data from the PLC using explicit messaging. Now I'm going to write data into the drive from the PLC using explicit messaging. I'm going to modify the AS to put it in hybrid mode. So again, I insert a rung. Create a new message. This message is going to be set AS. Open the configuration dialog. The instance in this case is a 1. The attribute, the class is 6A. Attribute is 2. This information is all available in the IP manual. Source element is drive AS. Again, your communication path has to be MDrive, and the tag is your message tag. And now I'm going to Go online with that. Download. Yes. Okay, now I'm going to take this value of 2, which is set here, and I'm going to send that data to the drive by toggling this command. Over here, if you receive errors, that means you didn't set the message up right, and it will give you error codes in the bottom to help you find out what you did wrong. This pretty well shows you everything that you need to know to implicitly and explicitly communicate with an MDrive from an Allen Battery Compacts PLC.